My talk is about best practices I can think about when coding in JavaScript, and based on my experience in software development during the past 25 years in Java, C#, and similar static type programming languages that allow us to define classes and use them. As we all know, the possibility to define a class in JavaScript is relatively new. Not all developers use that possibility properly. Some still prefer the old way, and underneath it is still the old way. In JavaScript, we don't have a mechanism similar to what we have in Java, for instance. In JavaScript, the inheritance is based on the prototype. I placed a link for a nice video that explains what does it mean for those of you that are not familiar with the use of prototype. By the way, I'm not going to read from the slides. You can take a software which will do it better. I'm going to focus on the main issues on the table. And a part of going overview those best practices I believe we should adopt. There are, of course, other principles such as the solid design principle. I believe we can adopt as well. No doubt that if you choose TypeScript, it is the best. Going over all programming languages we have out there, those programming languages we can use and then transpile the code into JavaScript. I think TypeScript is the best option, and you can feel that if you check out what happens. For instance, in Angular, in the case of Angular, they chose to develop using TypeScript. Even though the other option, Dart, that comes from Google, still they chose TypeScript. So of course, if you know TypeScript, I'm in favor of using TypeScript. But if you're stuck with JavaScript for some reason, still, you can make an effort and write better code. You can create better programs. After all, creating a program that works is not a problem usually. Usually most developers succeed. The question is about the quality of the code, how flexible it is to introduce changes, and how simple it is to fix bugs when they happen. So if we want our code, if we want the quality of our code to be high, we better learn from others with years of experience coding using programming languages that allow the use of classes. So I want to start with a simple code. Over here you can see a definition for a class. A class, its name is person. And you can also see that we have another class that extends person. The first thing I want to refer is the use of private access modifier in JavaScript. I found that many developers are not aware of that possibility. And when you define a class, in this case, we define the class person, defining those two variables, ID and name, as private means that you cannot access those variables unless it happens within the scope of the class. And a best practice when using Java, C# and so on is defining the variables, those variables in our class, that every object will have them as private. This way we can enforce a validation test whenever we want to assign a value to any of those private variables. We are forced to do it using a method. Usually in other programming languages, we call those methods setters and getters. Now, over here, we see a definition for a function. The syntax is a bit strange, and I found that many developers are not aware of that possibility. Take a look at this function, set ID, and this one, get ID. Those two functions are actually the implementation we have in JavaScript for what we know in other programming languages as properties. However, if I use the word property in my talk, it will be confusing because we use the word property for something else in JavaScript. So let's agree that I will use the two words classic property, or property in its classic meaning. If you take a look at the evolution of the programming languages we have out there, starting with Java, then you can see that when C# emerged, it was possible to define classic properties in those classes we defined in C#. And the meaning of, and afterwards, other programming languages followed, Scala, Kotlin, Swift, TypeScript. And when you define a property in its classic meaning, a classic property, in the documentation of JavaScript, they call it differently, but I prefer to stick to the use of property because this is the common term in other programming languages. It is about defining usually two functions. In this case is this function and this one, two functions that the use of these two functions will be as if they were kind of a new variable we want to access. So later when you try to, even here in the constructor, when you try to assign a value to this .id, you actually invoke this function, which is the setter part of the so-called classic property that its name is ID. And when you try to get the value of ID, it is actually an invocation of this function that returns the value of that specific private variable that was defined in the class. So this is a best practice we see in other programming languages, starting with C# and after C#, as I told you, Scala also allows you to define properties. Java still doesn't allow you, but Python allows you, TypeScript allows you. Kotlin even took it further. In Kotlin, you can't define a class with a variable. Anything that looks like a variable in a class is actually a property, a classic property, the property in its classic meaning, as in other programming languages. So I recommend that if you define a class in JavaScript, make sure that the variables are defined as private, and then define the so-called two methods. Here, these two methods are for handling this variable, and these two functions, these two methods are for handling this variable. And by doing so, from that moment on, whenever we refer ID, it is actually a call either to this function, if it is about assigning a new value to ID, or a call to this one. This allows us to introduce changes over time in our definition for this method, for instance, in order to change the validation test we want to have. The rest of the code doesn't need to go through changes. We don't need to introduce any change in the rest of the code just because we change the definition of this method. It allows us to be very flexible over time. Whenever we want to change the validation test, we just change it, and automatically we fill that wherever there is trying to access that variable, that specific variable for which we define the pair of these method, these two methods, or these two methods. So this is the best practice I know from those other classic programming languages. I believe we should adopt when coding in JavaScript. If you use TypeScript, it looks even better. Another thing I want to refer in this code sample is the possibility we have when defining a constructor to use the word super in order to invoke the constructor that was defined in the parent class. This is also something I paid attention to. I noticed that many developers, even experienced developers, don't pay attention to. And I want to explain. Technically, we could define this constructor with lines that take care after the assignment of name and ID. We didn't have to call using this keyword to the constructor that was defined in person. Technically, it could work. However, by insisting on separating the building process of a new object. Think about a new object that is created from the class student. The building of that object includes many things that should be performed. The separation between the constructor of student that takes care of assigning average and the constructor that was defined in person that now takes care after assigning ID and name, not only that it fits the SRP design principle I'm about to talk shortly, it puts us in a very safe place. Because in the long run, if someone decides to change the code of the person class and maybe introduce few more log messages, or maybe introduce something else that should happen when a new person object is created, thanks to the fact that the constructor that was defined in student actually invokes the constructor that was defined in person, that change that will take place in the future will also we shall feel it when instantiating a new object from the class student. We need to think about these two types, person and student, as two types in which student extends person. Whenever we instantiate student, we get a new object, and that new object, we can tell that it is a student, but we can also tell that it is a person. By linking between the two constructors of these two classes using this line, whenever we change the code in person, in the constructor that was defined in person, that change will take effect not only when we instantiate person, but also whenever we instantiate student. And that thanks to the linkage we created between the two constructors. So this is a best practice, not only in JavaScript, but now we are talking about JavaScript. This is a best practice relevant for other programming languages. And based on my experience working with software developers in many IT companies, this is what I do for my living. I noticed that many developers are not aware of the importance to connect between the two constructors using the super keyword when coding in JavaScript, and when coding in other programming languages, then do it using the syntax in those other programming languages. Okay, So I summarized those small explanations in these slides. A few words about the toString method. It is a good practice to define that method in every class we define. This way, whenever we need to create a detailed log message, it would be simpler because we can take the object and immediately get a text that describes it. So this is a good practice. I recommend you to define the toString in every class you define, just as you can see over here. One more thing before we move forward to solid. Handling exceptions. Well, the exceptions handling mechanism we have in JavaScript is very similar to what we have in other programming languages. I'm not talking about the case when our code includes definition for asynchronous functions, because in those cases we use a callback function or we use a promise. But when the case is a simple synchronous code method that works and we wait till it's finished, and if something happens, it throws an exception, I recommend, even though it's not a must in JavaScript, I recommend on defining a simple new class that we will use. As I will show you shortly, you can define a new class so that whenever exception takes place, and new object of that class will be instantiated and it will represent that exception. This way, the exception will be described using an object with variables that holds additional data. It would be a better way to handle exceptions in the long run. I recommend whenever you define a library, and if you are not using TypeScript, if you use TypeScript, then this is the direction you go anyway. But if you are, for some reason, still using JavaScript, then define a new exception class and just instantiate a new object from that class whenever exception happens, and we need to throw that exception. So the catch block will catch an object that describes the exception. It would be more useful than just catching a simple string. Okay, so we have a few minutes and we should end because I don't want to take time from your break. Solid design principles are, solid stands for 5 design principles. You can find it in the summary. The first principle is the single responsibility principle, and basically it is about whenever you change the code of a class, it should be only for one reason, for fulfilling the purpose of that class. For that reason only. So if you think about that principle, and of course you can take that principle and implement it when defining not only a class, it could be a library, it could be anything. Thinking about this principle, it makes sense what we talked about before when explaining the need to separate the building process of a new object between the two constructors, the constructor of the class student that takes care about whatever is relevant for the object as a student, and there is the constructor of the class person that handles the initialization of ID and name. This way, when we separate the building process, we stick with this responsibility. Another example for sticking with this responsibility, if you think about defining a class, for example, the class car, then we think about having a class that whenever we instantiate it, the new object represents a specific car. So adding new variables to the class car related to the engine, it isn't exactly according to the SRP principle. It would be better to have separated classes. Another principle is open-closed. And you can find the citation that explains. By the way, this topic is not simple. If you are not familiar with solid, learning those principles feels similar to learning object-oriented programming. it doesn't happen at once. It takes time. The best way, in my opinion, is listening to different explanations, putting everything together and think about it, because the explanations themselves are very theoretical. It's not simple to understand properly this topic, just as when learning OOP, object-oriented programming. Well, this principle is about basically, let's define a class that it would be simpler to extend its capability without being forced to modify its code. So for instance, if you take a look over here, we have two classes, checking account and saving account. If we have a class customer and there is a method, its name is get customer value, this code is awful because it checks whether the object is a checking account or a saving account. And if we suddenly have another class, a third class, so not only checking account, saving account, we also have foreign currency account, then we need to change the code of this function, get customer value. This is not a proper way for coding. It would be better if we define kind of, well, we don't have in JavaScript the possibility to define an interface. We can't define an abstract class, but we can define something similar. So we can treat the class bank account as a class that we can't, well, we can't instantiate it. We can instantiate it, but it won't be useful because calling get value won't get anything. So bank account serves as kind of an interface. And then we can define classes that extends bank account and override the get value method. And by doing so, if you take a look at this code, now if we have a new type of account, now if we have another class, its name is foreign money, foreign currency money account, all we need to do is define that new class as a class that extends person. And by doing so, we extend the capability we have when using customer without the need to change the code of the get customer value. Another principle, Liskov Substitution. Well, it is about if you want to code according to this principle, then you want to allow the bottom line switching between one object to another that extends, was instantiated from a class that extends the class from which the original object was created. Or in other words, here in this code, we have bank account, we have checking account. Now, if we stick with the Liskov substitution principle, it means that it would be simpler to work with, it would be very simple to work with an object instantiated from a checking account instead of working with an object instantiated from bank account. This switch can be achieved, will be possible only if we stick with the best practice regarding the constructor. Only if the constructor in checking account will include a call to the constructor in bank account. Only then, any change that will take place in the definition of bank account will also impact object instantiated from checking account. So if you want to stick with the Liskov substitution in this case, for instance, make sure that the checking account class includes a call to make sure that the constructor in checking account includes a call using super to the constructor in bank account. Otherwise, you don't do it, then changes over time in the code of bank account might make it impossible to replace an object that was instantiated from bank account with an object instantiated from checking account. So this is my words regarding this Liskov substitution. Interface segregation. Well, we can't define interfaces in JavaScript. However, we can do something similar. We can simply define, as we saw, a class with methods that include code that throw an exception, and by doing so, we can bottom line say that web browser is actually an interface. So the interface segregation principle is about separating to multiple interfaces instead of having one huge interface. If you don't separate, you will find yourself in cases where you can't implement all methods, and the code will become more difficult to maintain. So in this case, if you want to stick with the interface segregation principle, instead of defining such an interface, let's define two separated interfaces. It will be better. And of course, if you are using TypeScript, the best. Dependency inversion principle, you might have heard about it. Well, instead of, for instance, in this code is not according to the dependency inversion principle, because here, when we instantiate a car, we find ourselves stuck with a specific object from a specific class that represents the engine. It would be better to allow developers to decide by themselves which object will be the engine of a new car represented using an object instantiated from car. As you can see in this code sample, if we take outside from the code of the class car, outside somewhere else, the power to decide about the engine that is going to be used, then the quality is better. We get a better quality. Okay, the conclusion, think about TypeScript. Any question before we go out to our break?